All right, we're in chapter 2-1, Power and Radical Functions. And here we're on page 87. It's going to continue over on to page 88, where we're looking at example 2, functions with negative exponents. And we're being asked to graph and analyze each function, and also to describe the domain, range, intercepts, end behavior, continuity, and where the function is increasing or decreasing. So on page 88, example guided practice 2a, we've got a function negative 1/2 x raised to the power of negative 4. So we're going to graph this right quick. So we got negative 1/2 x caret negative 4. Now this negative exponent is going to make this a reciprocal function. Of course, it's got a transformation with the negative 1/2 coefficient there. And we should know, if we've got a negative exponent, that we should see some infinite discontinuity. So let's graph this thing. Zip, zip, zip. Okay. So here we have the graph of this. And one of the reasons why I wanted to graph it, it might look like, because we also have to describe the intercepts, that this may be moving right here along where y is equal to 0. Always x is moving from negative infinity, because it's really close to the x-axis there. But if we go into our table, we can see here, of course, when x is 0, there's our point of discontinuity. We've got the error that it cannot equal 0. Remember now, the variable is in the denominator. We can't divide by 0. But I can see, for instance, when x is equal to negative 7, well then y is equal to negative 2 times 10 to the negative 4th power, which means I would then take that 2, so I've got a decimal after the 2, I'm going to move it 4 spaces to the left. And so that's actually, that number is actually 0.000, or negative 0.0002, which is what, negative 2 10,000ths. Close to 0, but not quite there. All right, we're going to go ahead and jump over here to the, I did a screen capture of the graph, and we will then analyze and describe the various things we've been asked to do. All right, well, here we see the graph of negative 1/2 x raised to the power of negative 4. And we are going to then describe our domain, range, intercepts, end behavior, continuity, and where the function is increasing and decreasing. So let's begin with the domain. Well, we can see here, as x is coming from negative infinity, we've got negative infinity, comma 0, parentheses, in union with 0, infinity would be our domain, where we've got a restriction in the domain at 0. And in this particular graph, our range goes from negative infinity to 0. We do not cross on the vertical axis. We do not go above the x-axis. We have no intercepts, and again, one of the reasons why I actually took the time to actually graph this on the previous slide was to show that while it looks like we may be getting at 0, y equals 0, we're close, but we're not quite there. And let's see, I think next is our limits. Yeah, as x is coming from negative infinity, f of x equaling 0, and we have a limit. In other words, we got a limit of f of x or y at 0 as x is coming from negative infinity. And we have, as x is moving towards infinity, we also have a limit at f of x equals 0. Now we should be saying yes, we've got infinite discontinuity where x is equal to 0. And on our increasing and decreasing, again, as we're reading this graph from left to right, we are decreasing as x is coming from negative infinity to 0. And as we move beyond 0, going out towards infinity, we are in fact increasing. So there we've got the descriptions of this negative functions with negative exponents. All right, well, let's graph the second function that we've been asked to graph, which is 4x raised to the power of negative 3. So we got 4x caret negative 3. Again, it's going to be a reciprocal function where x is in the denominator. X cubed actually is in the denominator. Let's take a quick look at the graph here. And again, I'm going to just take a quick peek at the table. And let's see, I'm going to scroll down a little bit, go to the positive values of x just for the fun of it. Let's get it down. And I can see, for instance, like even when x is equal to 6, well, then y is equal to 0.185. It's getting, as x is going out towards infinity, y is getting closer and closer to 0, but not hitting it. I've got this arrow where x is, in fact, equal to 0, which is going to represent my point of discontinuity. We cannot divide by 0. And so, therefore, let's go ahead and we'll describe the graph of this function on the next slide. And so here is the graph of our function, 4x raised to the power of negative 3. Our domain is going to be negative infinity to 0 in union with 0 to infinity. Our range is going to be a little bit different on this one in that it is going to be, our range is negative infinity to 0, also in union with 0 to infinity, as we've got our graph represented in the first and third quadrants. That was a little different from the one that we did just previously. Again, there are no intercepts. Our limit is, as x is moving from negative infinity, we have a limit where f of x is equal to 0. And as x is moving to infinity, we have a limit where f of x is equal again to 0. We've got infinite continuity again, just infinite discontinuity where x is equal to 0. And on this particular function, we see a little difference in our increasing and decreasing. As I'm reading this from left to right, I'm over here in the third quadrant. Well, I am decreasing as x is moving from infinity going towards 0. And as I'm reading in the first quadrant from left to right, as I'm coming from 0 out to infinity, x going from 0 out to infinity, I am also decreasing. So there we go. We've looked at negative exponents. We've described domain, range, intercepts, end behavior, continuity, increasing, decreasing.